Hey guys, we just watched a video where I talked about the 10 different sort of forms of energy that you find in the universe. And then I want to put that in the context of the law of conservation of energy. So energy can neither be created nor destroyed, only transformed. So if I were to take this movement energy, it's called kinetic energy, I pull it up, this pendulum, and I drop it, what happens? Well, the energy is going to leave this pendulum. It's going to go to these other balls, right? It's not going to disappear. We're going to see it travel from one to the next to the next to the end and then back again because the energy just keeps on trucking. Okay? So this idea shows us that energy can be transformed from one object, this one, to another object. Some of the energy is kind of lost in the form of heat and sound and a few other tiny losses, so it can't keep going forever. But it does show it doesn't disappear. It just keeps recycling back and forth. These are very similar objects. What happens when energy changes form? Let's take a look at that. So here I have something called it's called a Stirling engine. So what Stirling engines do is you either get a really, really cold or really, really hot cup of coffee or tea or water, and you put this engine on top. Now, hot water turns into steam. The reason it turns into steam is because that heat energy is making all the molecules bounce around really fast. So there's this motion energy and heat energy coming from the hot water in my mug, okay? And we want to transform that into a completely different type of energy. And the type of energy we're going to transform it to here is called mechanical energy. So the energy of machines and motion, right? So what you do is you give this little wheel kind of a nudge to start it out. But then the idea is it keeps going because of the heat energy that's being released into this little piston in the back by the steam in the cup. So it's going to keep going. Hey guys, we just talked about the 10 forms of energy in the last video. Now I want to focus on transformation of energy because it can't be created or destroyed. So how does energy change forms? We're going to look at a few different ways. And the first way I like to look at transformation of energy is through something called a Stirling engine. Now, this engine doesn't have a battery. It doesn't have a source of energy. What you do is you get a super hot cup of coffee or tea or water or whatever, and that hot water, those hot water molecules have energy in them. The hotter they get, the more they're bouncing around, and that's why you get it turning into a liquid to a solid, and then this sort of steam energy pushes up through this piston, which can keep this wheel running for a while. So what we're doing here is we're transforming the energy of heat, thermal energy in our hot water into mechanical energy in our engine. So you have to give it a little nudge to get it started, but then it should keep going for a little while just based on the thermal energy being provided to it. So Stirling engines, they can't go forever because there's friction and there's air resistance and, you know, all sorts of different things working against them, but they can keep pumping for a little while based on this transformation of energy from hot water, from heat, from steam, all the way to this like rotating wheel that can do work for us. So these are kind of cool. And if you come into class, I'm glad to show you this. If you're in person, if you're online, you can stop by and take a look at this one day. But I'm going to put this to the side. It'll keep going for a little bit. I also want to show you another type of transformation. So if we have a battery, right? Inside this battery are all sorts of different chemicals. So some batteries have lithium. They all have nickel. They can have all sorts of different chemicals in them. And what a battery does is it takes chemical energy and turns it into electrical energy, right? And then humans take electrical energy and turn it into all sorts of other types of energy. We use it for video games, we use it for microwaves, we use it for cars, all sorts of things. So in this case, I'm going to take the chemical energy in this battery. I'm going to hook it up to sort of an electrical conduit, right? These two wires through which the electrical energy will flow. And then it's going to be transformed again into, hypothetically, light energy and a little bit of heat energy, because if you've ever touched a light bulb that's been on for a while, they're really quite hot, right? So I just connect my wires here, and I've transformed all of this cadmium or nickel or lithium or whatever kind of battery I'm looking at first into electrical energy, and then that electrical energy has turned into mostly light energy, but also some thermal or heat energy. That's a transformation. It's not perfect, it's not efficient. So we're losing some of the energy to heat and light, mostly the heat, throughout this process, okay, whether we mean to or not. But we have enough energy to light our light. And then we have one other little example here, and that's a Newton's cradle. So I'm going to shift the screen. You guys have seen these, right? Newton's cradle. The idea is that I'm lifting this pendulum up. I'm giving it something called potential energy, because right now it's not energy in motion, it just has the potential to be in motion. And if I drop it, what happens? Does that energy disappear? Does it travel? Where does it go? So I drop it, and you see that it travels from the beginning pendulum through each of these and then back again. It won't keep going forever because there's friction, there's air resistance, and you're losing some energy in the form of sound as they click together. You're losing a little bit of energy as heat. But the idea is when the energy disappeared from this pendulum, it went somewhere, okay? You created this new energy of motion and sound and a little bit of heat. Okay, so we call this Newton's cradle. It's kind of a cool experiment or exercise in conservation of energy. So these are all kind of physics examples of the conservation of energy. We're going to be really focusing on ecology and the conservation of energy. But I wanted you to understand the basic concept and the basic types of energy before we launch into that. So again, thank you guys. Let me know if you have any questions, and have a good day.